Hello, my name is Vyatkin. I've been working in information technology over 20 years across a wide range of projects, from engineering roles to executive leadership. Currently, I am a CEO of a deep tech startup, and today I want to talk about next generation of AI agents. What can we see behind current hype, and where is the current frontier? Okay, let's get to presentation. Next generation AI agents. Quite ambitious topic. But my goal is to bring to your attention something from scientific and research frontier and show you it as a quite deep rabbit hole. And if you like some, you could have a lot of fun building some knowledge around it and possibly some basic solutions or something. So, in this presentation, we will go over some consideration of current situation with AI agents in terms of hype we are facing, but how it's connected to reality, trying to see connections to next generation agents through building on first principles and active inference as a theory, as a framework, which is based on physics, biology, and our sciences. How it is possible to build single agents and then some kind of nested systems, and how it is possible to see it as a stepping stone for participation in technological evolution, again, starting from first principles and physics, maths, and so on. Yeah, as for current situation, last year was definitely a year of the agent in terms of new developments and hype what was raised around. Even through few months of this year, we see a lot of new projects and some crazy ones, and see even a shortage in Mac Minis, which is used to launch fully agentic solutions for people and developers and builders, but all of them still based on LLM approaches, generative AI approaches. They promise autonomous and multi-agent teamwork, working on complex tasks, and use cases that we're showing currently fuel massive excitement. But actually, we're still waiting for some real solution which will be in our everyday life. Following that, market booming. For last year, it's already around $8 billion and fast growth expected to 50 billions by 2030, driven by enterprise automation demands and working with industry and so on. But getting to some reality check, such agents still fail in novel scenarios. They still very data and compute hungry, and they still hallucinate. And we know how it goes when you get to something complex, and more complexity, giving more and more downfalls of approach. In terms of project, Holo currently started just through this year. Up to 70% of them have risks to stop working because of unexpected costs, scaling complexity, and other related risks. And it shows together a huge gap between that hype and actually true autonomy, true agency. And while promising, most agents still lack adaptability, still like working with some altruistic motivation, and with that setting opportunities for building next generation solutions. And for this presentation, I show information specifically about active inference as an example of such first principle framework. And let's get there. Yeah, some basics about active inference from that first principle consideration. It's as a theory, it's based and rooted in free energy principle, a theory which is developed by Carl Friston, most cited neuroscientist. And it posits that adaptive systems have some intrinsic capability to minimize surprise or prediction error to survive in entropy world, and it built it with unification on biology, physics, and application to artificial intelligence. The core idea of approach that agents reduce variational free energy or bounded surprise as some metrics, intrinsic metrics, which shows how different model of the world of the agent and actually the world and through perception and updating internal world models of the agent and through actions changing for world around is also possible. So that action piece is very important, not just inference and updating the models, but updating actual world around according to them. Yeah, and it brings specific action perception loop. And actually, action and perception could be considered the same phenomenon in this approach. And through sensing the data, agent can infer some hidden causes and update its beliefs on it, and then act to refine models or environment accordingly, and learning from outcomes, creating continuous adaptation for themselves. So, expected free energy is also the metric which includes consideration for epistemic value to explore exploration to reduce uncertainty for the agent and getting pragmatic values based on given generative models. So exploitation phase to achieve some preferred states of the agent, and why it's matter for building of artificial intelligence agents. It can provide intrinsic motivation for the agent and build it very efficient way, unlike our current approaches. And it enables true autonomy for changing and uncertain environments for such agents, and they can evolve through the time, built on first principles from active inference. Yeah, so free energy principles defines that all adaptive systems minimize free energy, operational free energy or surprise, and it's a physical principle for adaptive systems. Active inference is a theory or a framework built on it, and it defines that agents actively sample the world around to refine their generative models, and through that unify processes of perception, actions, and learning to be adaptive in environment through agent loop, which finding some different states for agent and environment in some informational symmetry, and loop of the agent on inference states predicts outcomes of its actions, selecting policies for specific actions, everything based on calculation for minimization of expected free energy. And if building on that, we can define agents and next generation agents like autonomous entities with a core of hierarchical active inference over generative models which are adaptive in their role. And if we are ready to build on that, we can get actually to enabling true agency and build on adaptation of such approaches and build on intrinsic motivation of such first principle agents in a new way. As for such agents, active inference agents advantages, they adaptive. They actually solved dilemma of exploitation and have it in some dual mode of handling uncertainty through epistemic foraging to reduce uncertainty, and by that outperform current approaches and get into and capability to work with novel scenarios without massive retrainings for the models. As for intrinsic motivations, we build it on that biology principles. It is possible to get to goal-seeking and curious behavior which emerge from such first principles, and it's different from current only reward and reinforcement approaches. Such engines could work very efficient and by that be very scalable. And from scalability, it is also possible to build hierarchies of generative models of such agents. And they need quite low data and quite low compute for learning, which is again contrast them from current approaches. An important thing about explainability of such agents' behavior and then governance of their behavior. Through that approach, it's possible to have it inspectable about their beliefs of agents, about policies we are choosing. So it's reducing risks compared to current black box models with not understandable effects. So active inference is a multi-scale approach, and we can consider starting building from single agents through scaling to multi-agent environments, and on the same principles, and even on single scale for agent, it will be able to be real-time adaptive and be able to operate in uncertain environments with changes, with novelty. And that's important, for example, for robotics, when body control in changing environment still quite huge problem. And solving on that scale, working together, such agents can share the models of the world, keeping their own boundaries as Markov blankets, and building some nested structure with belief propagation from message passing, and working on expected free energy minimization for whole team of agent, and emerge orchestration from that collective behavior through common world model without central controllers is also a possible achievement at some moment. Yeah, active inference can be considered in the context of technological evolutions and like accelerating of technological evolution, because self-evolving agents can drive innovation. They can work and enable complex intelligence by mirroring biological and physical evolution mechanisms into digital world. They can work through collective faster discoveries, working with hypotheses in the same manner of epistemic actions as biological agents are, and with refining models and working as researchers and create some new ways of problem solving. It is possible to build resilient enterprise system based on them, because you could have that traceability on what's happening, and that orchestrated structure of multi-agent environment and workflows which are capable to adapt in real time and using the same principle on different scales through different parts of automation, robotics parts, and supply chains and our activities of organizations. And it builds bridge to systemic transformation and getting from isolated tasks for ecosystem-wide consideration, and finding some new business model, novel business model by such agents, even possible social structures, and at some moment getting to solve real global scale challenges. Getting closer to the end and just showing, that perspective that behind the current hype, it is needed to trying to figure out where is the next frontier, and getting for whole AI movement, getting to first principles approaches implementation, and here specifically for active inference for agents. I believe its implementation of it could really embrace true agency for such agents because of defining next generation through first principles for agents which minimize that free energy or surprise and able to be adaptive and be able to be efficient and be able to solve problems of current LLM-based approach limitations. Yeah, it's good to have in mind about that active inference providing solution for exploration exploitation dilemma, and it's leverage to create agents which work with uncertainty. By that, make them be able to operate in real world and in dynamic changing environments. And such agent can work in hierarchical nested structure and arrange some multi-agent emergent behavior and working as a single agent or teams, but with the same generative world models and doing the same in terms of minimization of predictions and surprise about the world and actions in that world. And finally need to get to some specific actions in that rabbit hole direction and trying to build the next steps in technological evolution. We need to start experimenting with the new tools which are available. Some projects are already and start in place, and some startups getting financing, and first robots work on active inference frameworks. Let me to provide you information about resources to get into rabbit hole. And first is a textbook from Par, Pizzolo, and Freestone. It's available for free on MIT resource by the link, and you can start from there. Next textbook, which will be available soon on fundamentals of active inference finally for engineers, which is good. Some libraries on Julia, on Python, with examples of basic agents working on active inference principles, which you can start play with. And the link to Active Inference Institute, where you can get much more information about information sources, some activities on collective education, and so on. So if you're interested in such approach, go through links, start getting information, start possibly building. And if you possibly have some questions, you can reach me out through this QR to LinkedIn. And thank you for your attention. And hopefully we will see some new approaches and new projects who are building on something real from frontier.